makes a projectile of himself, this time from the mouth of a cannon. A man fired in the air. All humankind in action. The universal laws of motion! Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Pushy People. When you need to get something moving, call Pushy People.
Everything in the universe, including you and me, is in motion. Now, forces put things in motion. Forces, like when something is pushed or pulled. To understand motion, you have to figure out if you're pushing on things or things are pushing on you. Whoa. Let me show you what I mean. We are right here. Right here. But we were over there. Over there. Here. After I came through the door, it looked like I was walking through the lab. And in a sense, I was. But I was on a platform. And I was standing over pretty much the same part of the main lab the whole time, till I fell off the platform. You couldn't separate the motions. Now watch them both one more time. Everything in the universe, including you and me, is in motion. Now forces put things in motion. Forces, like when something is pushed or pulled. To understand motion, you have to figure out if you're pushing on things or things are pushing on you. Whoa! Take a look at this. This is an air track. When the pump's running, air comes out of these little holes. And it can support the weight of a scooter, like this one. Now, when I place the scooter on the track and let go of it, it just sits there. It doesn't move unless I give it a push. Then it keeps moving unless I give it another push. Or it hits the end of the track. Or maybe another scooter, another scooter, another scooter. Now, here's the thing. If we had enough track and enough air, the scooters would keep scooting forever. There'd be nothing to slow them down.
Well, hardly anything. So when something's at rest or sitting still, it stays sitting still
unless acted on by an outside force. And when something's moving, it keeps moving unless acted on by an outside force. Outside force. Outside force. This is true of everything that you can touch and see. As you may know,
Inertia is a property of matter.
Inertia is a property of matter. A bowling ball weighs more than a golf ball. Right now, their weights are supported by these wires. But if I push them or make them run into each other, you can tell that the bigger one is harder to move. We call this property of matter inertia.
Inertia is a property of matter.
This is an anvil. It has a lot of inertia. And right now it's being acted on by an outside force. Gravity. But it's also being acted on by another outside force. The pull of the chain. Now, to get an idea of just how much inertia it has, we'll lower it.
What's that noise? Whoa! 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 Inertia. Whoa!
Now, just for kicks, this is another type of air bearing. The pump's on here. Now, gravity is still pulling it down, and the air pressure is holding it up. So those forces are in balance, but the anvil has a lot of inertia. And to get it moving, we need a big push.
Oh, no. Not this again. No, come on, Bill, please, no!
What's inertia? I'll show you. Take a playing card and set it over a glass. Set a quarter on top of the playing card. Flip the card hard with your finger like this. The card goes flying, but the quarter falls into the glass. The quarter has inertia. It's not moving, so it stays at rest. The card slides out so easily, it doesn't overcome the quarter's inertia, so the quarter stays put. Of course, once the card's gone, there's nothing left holding up the quarter, so it falls into the glass. Whether something's moving or sitting still, everything's got inertia.
Okay, we got everything packed away. Let's get them to get on the truck.
Here, boxes, boxes, boxes. Here, boxes, come on.
I think you gotta get tough with them.
Hey, boxes!
Hey!
Get on the truck!
Hey, why don't you try a little psychology?
Hey, I hear they're giving out free ice cream to the first 20 boxes that get on the truck.
Hey, says here that nothing gets moved unless they get pushed or pulled.
Great! That means we'll have to do the work, just like last time. Please!
Come on, you're so heavy.
Right
out here, just out the door.
Newton's laws of motion. First law, the law of inertia. Things at rest stay at rest.
Hi, Bill. I'm at rest.
Things in motion stay in motion. Unless acted on by an outside force. Second law, to move a mass, you need a force. Here's a mass,
Hey,
and here's a force.
it's hard to maintain this position, you know. Thank you.
And then in mathematics, we say force equals mass times acceleration. F equals ma.
So in order to get the same mass accelerating twice as much, you need twice as much force.
Woo!
Here's the mass, and here is twice as much force.
Yeah, for sure.
The third law, for every action, there is an equal and opposite reaction. Action, reaction. Equal and opposite, action, reaction.
Here we go again.
Two masses. This one's going to be moving.
Woo!
Action, reaction. One car moving against two cars.
Woo!
They move off half as fast. That's the equal and opposite reaction. Newton's laws of motion.
What do you think of that?
Life is like a boxcar of inertia.
And now, Newton's laws of motion. Tonight's episode, the first law.
An object at rest remains at rest unless acted upon by an outside force. An object in motion tends to stay in motion unless acted upon by an outside force. Let's watch that again in slow motion.
Without motion, you're just a potato on the couch.
Street luging is a highly modified version of skateboarding or butt boarding.
You get these babies in motion and there's no stopping it.
Let's do it. It's on. It's on. We push along the ground to get us started, and then we're under the will of gravity and the percentage grade of the hill to determine our maximum velocity and our speed. What we got here are brakes, our shoes, and our lifeline. Well, that's after one run down about a 50-mile-an-hour hill, so got about 2 or 3 more runs out of those, and I'll have to grab in for a new pair. To have motion takes motion. You either gotta push or pull.
Hey, keep it moving. Join the Inertia Dance Project for a very special evening of movement and motion. Choreographer Isaac Newton presents his world premiere piece entitled Bodies at Rest, Stay at Rest. Mimes not admitted unless accompanied by a speaking person.
This apple has inertia. It has mass. Right now, the scale is measuring the pull of the Earth's gravity on the apple's mass. Here in the plane, we have a lot of motion. But the scale reads just about the same because the apple still has the same mass. Which goes over. Yeah. Now, as we go down, the apple is falling at the same speed as gravity makes it fall. We're weightless. The scale reads 0, but the apple's still the apple. It still has inertia. But now, as we pull up, the scale reads higher because the plane is pulling you, me, and the apple up against the pull of gravity. We measure mass in grams or kilograms. So if I do this, the apple might be weightless, but it wouldn't be massless.
Spacetone News presents The Place, Space. The question, in zero gravity, do the laws of motion still apply? The answer, yes. Objects in motion in space tend to stay in motion unless something slows them down.
Move. Why won't you move? Go back to where you belong.
Use force.
Huh?
Use force. An object at rest will stay at rest until an outside force acts upon it. Use force, Luke.
Huh. It worked.
So, what'd you learn in school, son?
Nothing.
Son.
Okay. I'll show you. See, we learned that objects at rest stay at rest, unless, of course, they're pushed or pulled. But this cloth, because I jerked it so quickly, couldn't push or pull any of the objects on the table. By the way, nice choice of cereal, Mom.
That's my boy.
Hey, it's lunchtime.
Oh, okay.
Hey, stay right here.
Don't move.
Sure is quiet.
Yep.
Nothing moving for miles around.
Nope. Pa?
Yep.
There's something I gotta tell you, Pa.
What is it, Delilah?
Well, that last statement you made isn't entirely accurate. Although to you, the observer, it appears that nothing is moving, well, that is merely an artifact of your frame of reference. Like right now, the Earth, it's spinning on its axis at about 1,600 kilometers per hour. And the Earth is moving around that sun about 30 kilometers per second. Plus, our entire solar system here, why, it is just hurtling around the outer edges of the Milky Way galaxy at about 220 kilometers per second. Not to mention the movement of our galaxy within the universe. It's expanding at speeds approaching the speed of light. That's about 300,000 kilometers per second. So you see, Pa, we're all us here moving pretty fast.
Yeah.
We're all in motion. We're all in motion. Everything in the universe is all in motion. When things are pushed or pulled, they're put in motion. The more the mass, the more force we need. The more inertia, the more force we need. We're all in motion. That's what it seems.
I'm Bill Nye. Cars go this way while the road's going that way.
We're all in motion. We're all in motion. Everything in the universe is all in motion. When things are pushed or pulled, they're put in motion. The more the mass, motion.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some third derivative jerk functions to evaluate. See ya!
I never get used to it.
The dummy is no longer in motion. The dummy is no longer in motion.
Produced in association with the National Science Foundation.
I
love science!
Science!
Yeah.
Man, this is a ways down. Okay, here we go. Oh, man. Science! 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 It's science! 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 Just like this.